All right, I'll be kicking this off here. Welcome to the VIAME tutorial. I know a couple of you are still filtering in because the participant count is going up, but I'm Matt for those who didn't see our first presentation earlier on in this workshop. And I'm joined by my colleagues, Brandon and Ashish here this time around. We opted for WebEx instead of GoToWebinar for basically support of a global text channel so that people could ask questions while we're presenting. There's a lot of people here, so please keep yourselves muted unless you have questions at the end of each section. There's sort of three main topics we're going to cover here. And you can ask questions in the chat channel while we're giving these presentations, but at the end we'll have an open question section at the end of each of these three sections in case people want to unmute themselves and talk openly. That's one of the other advantages of this compared to webinars is that you can turn on your webcam and your mic. We ask that you just don't while the presentation sections are going on. So this tutorial was originally designed to be more of a hands-on experience for a smaller audience. Basically, though, due to the virtual settings and the large number of attendees, it'll be slightly more presentation style this go around. Obviously, just due to the unfortunate circumstances surrounding COVID. Still, though, I encourage people to try to follow on in both the web and desktop portions of this tutorial when possible, or alternatively, after the tutorial, we will be making videos available of this. We will be moving sort of quickly through a lot of the content just due to time limitations and covering a bit of material here. But we will be spending more time on sort of some of the basic concepts like loading data into the web interfaces, the desktop interfaces, the command line tools, then going through some of the features of each interface a little bit faster. So I wouldn't try to do everything that we're doing, just different portions, and we'll try to clarify which. It is going to be a weird sort of mix of things you can follow along with through the web interfaces, the desktop interfaces, and things where you might just want to be paying attention to what we're showing, because we're going to be showing a lot of different features in sort of a rapid succession. Most of what we're showing here today is targeting machine learning beginners, but we will jump to a couple sort of advanced concepts a couple times here and jump back again. So there is a large diversity of people here with different backgrounds. Some people have machine learning backgrounds, some have absolutely none. So we are going to try to balance this and rotate between the two back and forth. Starting for the first 15 minutes or so, I'm going to give a quick overview of basically training some machine learning models, capabilities that our toolkit supports right now and where we're going. And we're going to cover the web edition for probably 35, 40 minutes-ish. Should bring us to around 1 o'clock, and then cover the desktop edition and sort of the command line tools at the very end. So essentially, this tutorial is going to get more advanced as the day goes on in terms of difficulty. But we're going to try to balance some of these. Most of the day, at least for the first hour and 20 minutes, I'd say, is focused on these three core tasks here. So object detection, tracking, video search, and rapid model generation. That'll probably be the bulk of this session. It's the most generic, and it tends to, bring in the largest audience. But towards the end of the session, we will be sort of quickly going through examples for these other things on the desktop side: image enhancement, stereo measurement, calibration, and 3D. These will be speed talks. Again, we will be focusing mostly on those first three core bullets. Just looking at the responders here, we had roughly 165 responders, people who signed up. We have maybe 90 people here, so not everyone made it. But looking at the distribution of what people were interested in, programming APIs was number one, and that'll be touched on a little bit, but not too much. More so towards the end of the tutorials. The first section will mostly be covering the GUIs and train tools a bit more, but we will cover it a little bit more towards the end. In terms of interfaces we have in the system right now, there's really three core ones. I covered this a little bit in sort of the first presentation we had earlier on in this workshop, but we'll be covering them a bit more in detail today. So at the front end, we're going to be going down this list today. We have the web annotation and annotation archive. We have a public version of this. For this training session, we also hosted one on AWS as a backup. So there's really two websites you can go to and start messing around with. You can log into those websites right now. Ashish will be covering that a little bit more in a minute. We have desktop interfaces, which will be the second pass of this workshop, and then command line tools and APIs, which will be the third pass towards the very end. But we're going to quickly run through those in about 20 minutes at the tail end of the tutorial. In terms of interfaces, we do have, 3 core different interfaces. There's 2 desktop interfaces and 1 main web GUI, and we'll cover the differences between them a little bit more later on. We are working on merging them, so there is just like a single interface to the entire system on the GUI side. GUI standing for graphical interface for those who don't know. But right now we do still have sort of 3 disjoint GUIs. They have roughly the same features, but there are some basically applications that are in one right now, not the other. For example, stereo annotation on the desktop side, video search on the desktop side. We don't have those in the public web GUI yet, but we're working on normalizing those a bit. That said, all 3 interfaces, they share the same processing backend. So the pipelines, the backend analytics, they're all the same across these 3 interfaces, so they don't change at all. So you will see a lot of commonality between them today in terms of functionality and in terms of things you can do in them. File formats are also compatible. So for example, if you do annotation in the web interfaces, and then you want to save out your annotations, bring them to the desktop side, you can do that. They're not mutually disjoint tools. So you can do annotation in one, for example, and then train on the other. On the more advanced side, there's base classes for different common operations like image filters, object detectors, trackers that can be derived in sort of C++, CUDA, Python, or MATLAB. I won't be covering this too much until the last 20 minutes again. The backend itself is coded in C++ for efficiency. In terms of installation, for those who want to try to do a hands-on for the desktop portion, I would advise you to download the desktop binaries right now. That'll be the second half of this tutorial. We'll be covering the web interface first, which does not require any downloading ahead of time. You just go to a website and log in. Ashish will be introducing that in a little bit. But basically, for installations of VIAME, we provide, 3 or 4 different sources depending on the desktop or the web version. So the desktop is traditionally available as a .zip file containing binaries. To install it, you basically download it from the website. You extract the .zip file on your computer. We'll be covering that a bit more later. We also make it available in Docker format in case people want to just install the training tools on AWS, for instance, and just do training headless, headless being without the GUI interfaces. So say you do annotation on the desktop, but you want to trade in the cloud. That's in contrast to the web version, which is mostly available in Docker format. Docker, for those of you who don't know, it's basically just like a really lightweight virtual machine where the entire instance is contained in one Docker file. They could just spool up on your machine and host. I have to apologize to Mac users here because I didn't get Mac GUIs out in time. It is on my agenda because I've gotten about 5 things about this over the past 5 months. So it's in progress. It just didn't make this tutorial. The alternative to installing sort of the pre-built binaries for you developers out there is building it from the source. Both of these tools are open source on GitHub, and that allows you a bit more customization in case you want to turn on and off different features. The reason I'm recommending downloading the desktop interface early, for those of you who want to follow along with the second half of the tutorial, is that it's 4 gigs big. That's due to the inclusion of, I guess, 8 to 10 different default model files, which are like 300 megs each. So it does take a little bit of time to download, probably 10 minutes. The CPU-only versions are about 2 gigs, simply because they're much smaller. They have maybe half the models. For those of you who are interested in building the software, it basically uses Git and CMake to do cross-platform builds. It is written primarily in C++, but with Python derivations of classes like detectors and things, because a lot of machine learning work is happening in Python these days. And we also have Python interfaces that we've been working on. We don't have a PyPip package yet for running the analytics, but we're working on that. It should be in place soon. All right, just briefly covering GPU versus CPU. A lot of you work with machine learning already. Some of you don't. But we do expect, sort of by default, that you do have a GPU in the machine that you're hosting this on. And by hosting, I mean it's different in the desktop and the web GUI case. In the web GUI case, you might have a central server with a GPU in it, but the clients, the people logging through on the web browser, they don't need a GPU. The desktop side, we do recommend having an NVIDIA graphics card. They vary a lot. We typically recommend one with 8 gigabytes or higher virtual RAM. That said, though, there's a lot of capabilities that you can run in CPU only. On the GitHub page, the installer list, there are both GPU and CPU binaries. CPU binaries, you can still run the annotator. You can run some analytics, but not all of them. So there's different levels of analytics in the system. Some are rapid pass models that they generate very, very quickly. They're not traditional deep learning methods, so they're not convolutional neural networks. These are things like motion trackers with Kalman filters on top that are just doing motion detection. Baseline pixel classification, so your more traditional machine learning pipelines that do like feature classification on fixed feature vectors. Those you can run on CPUs. Some algorithms are meant to run on a GPU, but they can run on a CPU, for example, deep frame classification. It's a little bit different than object detection in that the networks are slightly smaller. They can run on CPU, just slower, obviously. Some analytics are meant to run only on the GPU, and they sort of take forever to do on the CPU. For example, training deep convolutional neural network detectors. That's the biggest thing you're going to run into issues if you're trying to do CPU only. Documentation for these things, I'll be covering a bit more in the later desktop section. But there's really 5 sources. There's a desktop quick start manual on the installation page and the core website. I'll throw it in chat. This links to all the other material eventually if you go down through the short links in there. But there's a quick start guide. There's a web wiki and an in-GUI help menu for the web GUI that we'll be demoing in a minute. There's tutorial videos, which is a work in progress. We still have a couple more to do there. This is ongoing. Lastly, there's a developer's manual that has a bit more technical information, but it's getting more towards the developer's side, so things like C++ classes. But also in the developer's manual is a sort of example documentation for sort of each of the functionality. All right, getting into workflows a little bit. Within VIAME, there's really, I don't know, 3 or 4 core workflows for generating different object detections. We'll be going through these a bit today. So the leftmost side is sort of the easiest. Maybe there's an existing model out there, traditional or deep, trained near your problem, for example, detecting fish, that gets you part of the way there. So maybe you just run that detector and you're happy with the results, fish, no fish, and you're done. Often that's not the case. People have individual categories they're trying to detect, and they want to train models specific to those categories. And there's really 3 different workflows you can use for that. One, the most traditional one, is you do ground-up annotation. So you load up your raw video, you annotate it. We'll describe what annotations are in a second, but you put boxes around the targets, pixel level, mask, whatever, and then you train a model. After you're done training that model, maybe you're happy with the results, but maybe you're not. So you run that on more data, you correct more annotations, and rinse and repeat until you're happy with your model's performance. That's sort of traditional deep learning. A couple caveats. The sort of second stage up from that is a fusion pipeline, where maybe there is a detector pre-trained towards what you're interested in, or you trained up a previous detector that you're sort of happy with. You use that to bootstrap the annotation process. So you run that detector and you correct the results as opposed to doing things from scratch. The last sort of interface we have is a bit more custom. It uses active learning to basically do video search. You give it an example of what you're looking for. You mark off what's right, what's wrong, then you dynamically generate a model on the fly. We'll be covering that about an hour into this. In terms of annotations, there's really 4 types that the system supports. There's box level, frame level, pixel level, and key points. Box levels are just boxes around the target of interest. Frame level would be like a high-level frame descriptor, like this frame contains a property. Maybe it has fish, but maybe it's more macro-level properties, such as the substrate background, dirt, gravel, etc. Pixel level is basically more fine-grained than box level. You have a mask around the target or a pixel-level mask. It might have holes, it might not. Lastly, there's key points, which are traditionally used for things like stereo measurement a bit more. So you want to know how big an object is, but some people do actually use key points for detection problems too. So they might train a key point detector to go for the heads of objects and just count objects based on the head without explicitly localizing them. So detections versus tracks come up. In all of our GUIs, detections and tracks are sort of synonymous. The main definition, though, is that a track is a spatial temporal grouping of single frame detection. So a detection is a single box. A track is multiple detections over time chained together into a single object. All our formats support both of them. And in some places in these GUIs, we use these terms sort of intertwined. It's a little ambiguous because a track, you could have a single frame track, which is just like a single detection, a single state. So you will see a little bit of overlap in how we're describing these things. But for the most part, they're synonymous. And none of these things need to be exclusive. So you can have all these annotations together within one object. So you could have a polygon in a box, and a line for measurement. In terms of annotation formats, we really use two in the system right now. Traditionally, we've used what's called a VIAME CSV, which is a really simple CSV format with a couple extensions at the end. So this is things like box properties, optional target length, the confidence values for each of these fields. So what type of the object is, what's the probability of that type, or in the case of manual annotation, that field would just be one. But then there's a couple more optional attributes that can be edited at the end. Key point, track and detection attributes, we'll cover those later. Notes, polygons, links to masks. Traditionally, this came about because people were doing analytics in Excel and they wanted to continue doing that. So CSV is very good. It's a fixed format. It's simple, but it's not always as extensible as it could be. So we've also been working on a I don't know what this annotation request is, but I'll do it now. There's also the ability to do sort of Cocoa JSON. We have that in the desktop right now, not web, but we're using that as a secondary format because it's more popular in the let's get rid of this. In the what's it called? It's a bit more popular in sort of like computer vision academic communities because it's a bit more widespread in that community. So next slide. How do I get off annotation here? Someone submitted a annotation request for the slides, and now I'm in annotation mode, and I have to use WebEx. So I don't know how to get off. Annotate. There we go. All right, we're back to slide transition. All right, moving on. Sorry for that little interruption there. So annotation best practices. Typically, when you're doing annotation, you have to consider time versus quality trade-offs. In the best world, you do pixel level measurements and boxes, but obviously this takes a lot of time. If you're just doing boxes, it makes sense to put a box sort of evenly on that fish, where it's tightly around sort of the fins and the tail. You don't really want to include shadows in your boxes. But obviously in these things, people are going fast doing annotation for a lot of targets. Doing a traditional deep learning pipeline, you have to annotate a lot, so don't spend too much time on it. So there's really trade-offs. In terms of pixel versus box detectors that you're actually training up, the pixel classifiers typically do a little bit better if you spend a lot of time doing that, but it's really how much time you're spending on the actual annotation process and how difficult your problem is. That's what you have to consider in terms of what type of annotation process you're doing. There'll be a little more on that later. In terms of detectors we have in the system, you'll notice once you get up to using it, there are, I don't know, I guess 4 to 8 different detectors that you can train up. 1 to 2 trackers right now. Basically on this end, we have some basically baseline algorithms that we've integrated from the larger computer vision community. Some of these we sort of took wholesale, other open source solutions. Some we evolved into our training framework. We have a different training backend to basically train up these models. I'll describe a little bit more about which is which later, show them in the desktop portion, training up locally. But this slide is basically showing sort of high-level deep detectors that require a lot of training data. So these are detectors where you can't just do it on a single sequence of 10 frames. You do need thousands of frames, hundreds or thousands of annotations per category at a minimum, just to get working models. And doing more annotation, you typically get diminishing returns in terms of the quality of the models that you're training up. Then secondly, we have a lot of sort of smaller models that are more designed to basically bootstrap the annotation process. And there's a couple of them here. One is we take generic object proposals. So we take a model trained to put boxes around arbitrary targets, and then we train up an SVM classifier on top of those, basically descriptors around those targets to do a rapid first pass. So compared to the other methods, that requires a lot less annotations just to train up these models. We sort of do the same thing on the pixel classification side, and this is fairly new. I just added it to the source sort of yesterday, along with another coworker, is you have a first pass pixel classification model that's not actually a deep network, but then you use that to bootstrap sort of the pixel classification training for those larger methods. Because it might work on like a small video sequence, but it might not be generalizable to thousands and thousands of frames. Lastly, we have some full frame classifiers, which do typically require less annotations than the detectors, which might do subframe detection. but require sort of a medium amount of annotation. I'm going to briefly roll through some of these extra slides. We could actually get into the tutorial portion. But topics like ensemble classifiers are sort of advanced. I'll briefly cover that at the end. That's things like running multiple detectors together to improve their performance. We do have scoring tools in sort of the desktop version. We don't have that too heavily in the web right now. Web's a bit more specialized for training detectors, training trackers. But again, more on that later. Basically, our backend training harness, so we do a couple things to try to reduce the number of annotations that you need to train up models. One is we use seed models that were trained up on sort of wider vision problems like the COCO challenge, for instance. Two is we have a ton of soup-to augmentation that we do to try to minimize the number of samples. This sort of fusion task here is doing things like taking motion detection, fusing that with RGB, and infusing that information into detectors. Basically, what that amounts to is a different config file that you use to train either the web or the desktop side. Object tracking comes in three different forms. Some are utility pipelines used for generating additional annotations, which is what this video shows. The user basically is drawing a box on the target, running a short-term tracker. That way they don't have to annotate that entire track manually. So that's one application of tracking, is speeding up the annotation process, but we have basically pre-trained models for two other trackers in there. One is just a default tracker. If you have a detector and you want to turn it into a tracker, you run that model. The other is a non-deep learning model. It's basically using frame-to-frame stabilization to track the same target over time. So you use image features to register neighboring frames into a mosaic, use that to basically suppress duplicate trackers, duplicate detections. That comes up a bit more in sort of the aerial domain, such as on the top right there, where you're linking seals or sea lions. So after these initial detection tutorials, we're going to be doing some speed tutorials, and I'm briefly touching on these slides. Literally up probably like a minute or two each, except for this first one here. Going through some of the examples in the example tree on the desktop side, but we'll be doing basically this concept of rapid model generation. So that's where, I'm not going to play this entire video here, is in sort of the first presentation. That's where you're giving it a image query of what you're looking for. In this case, the user supplied let's see if I can bring it up here. Flounder early on, they selected the flounder. The system applied ranked return results. And the user goes through and sort of iteratively annotates them plus or minus. Probably spend about 10, 15 minutes on this, around 1:30 or so, in a faster talk. Lastly, these sort of auxiliary cases we are going to roll through, but again, it's going to be fairly fast at the end. So full frame classification, which is very similar to training detectors. Enhancement, calibration, and depth estimation. I'll run through there's a question in the chat channel here. Can the search and rapid model generation be run on the CPU? And that's a very good question. The default pipeline is very GPU intensive. So I wouldn't really recommend it. It's going to take a really long time to do basically this initial index stage where you have to create a searchable video archive for your query before actually doing that query. What you can do on the CPU, though, is full frame matching and full frame IQR. That isn't too computationally intensive, and so people have gotten by on the CPU. But the detector level IQR and tracking level IQR typically does require a GPU. So full frame classification is classifying the full frames. For example, substrate type, or in this case that's a penguin cam. They want to know when it's surfacing. They want to know where there's krill in the video. That's a solid example for that. And likewise, similar to the other examples, there's two models here. There's an SVM for when you don't have a lot of annotations, and then there's a deep model for when you do have a lot of annotations. We try to balance those models. Enhancement, we'll be rolling through and running enhancement through the desktop GUI. We don't have enhancement on the web GUI side yet. You can't run filtering options. That said, though, some of the pipelines on the website do run these things under the hood. And then these sort of arbitrary pipe files that you can define, you can run them in the web interface right now. You just can't save out from the GUI interface corrected frames and whatnot. But we'll be touching on that briefly. Registration and mosaic, I'll run through a quick mosaicing example just when running through the example tree later. Stereo measurement, also very quick. Similar to the others, we have two methods we've been pursuing, sort of a non-deep method, and based on some work from Chris Williams, and a deep method. And lastly, I promise this is my last slide before we sort of get into the guts of the tutorial a bit more, is sort of doing pixel classification and the actual code infrastructure. If there is time at the end, I'll cover it, but we'll have to play that by ear. The VIAME is an ongoing development effort. It's not like a solidified project. We are actively doing development on these GUIs and these interfaces. So we do typically put out releases every couple of weeks. There was a comment in the chat clarifying pre-processing the image/video archive should be run on the GPU. So it does deep learning detection and feature generation on all images. The interactive functions, querying, communicating results, refining the list are all run on a normal CPU. I think that's in reply to the comment about IQR and whether or not that runs on the CPU or not. So come back to this slide. It is an active development effort. Sort of some of the near-term things we're working on is basically improving the default models in the system. Right now, all the default sort of generic fish detectors are about 1 year old, and we've done a bit of work on the detectors since then, particularly motion fusion. So we actually have a couple new models that are training right now that didn't make it into this presentation, but they will be in releases shortly. Typically, we do a release maybe every 2 weeks on the desktop side. WebGUI is actually automatically updated weekly on Sunday mornings. So there is sort of a fast development cycle. Additionally, some pixel level classification support was sort of just added. We can only briefly cover that today, but there'll be more of that in the next couple of weeks. Documentation is also high up in our list. Midterm, we're trying to normalize the web GUIs and the desktop GUIs a bit more, just so they're more in sync. Right now, we do have 2 separate interfaces, but we're working on just having one so that the process is a bit more streamlined. Longer term, basically going for additional algorithm specializations, so behavior and event detection, and additional acoustic support. So with that, I'll post this slide up at the end just for feedback. We have sort of 2 development lists. If you have any comments about the interfaces itself, additional questions. And we're going to start the second portion of our little workshop here, unless people have any questions they want to raise up. And with this, I will be passing this section off to Ashish and Brandon, who will be covering our web system.
Thanks, Matt. That was great. So I'm Ashish. I'm going to talk about the VIAME web software and how we deploy this software on multiple platforms and environments. So we aim for high quality software and software that is sustainable. And towards that end, we embrace open source software tools and technologies, including Kitware's own open source tools such as GeoJS and Girder. We primarily use GeoJS because that's something is highly customizable software for rendering of the scientific data sets, whether it's in a map context or not. In the case of VIAME, we don't use the mapping. We just use it for rendering the mid to high resolution data sets over the web. And then we use Girder for essentially providing us the data API that makes it easy for us to build an application like VIAME Web. And I'll talk more about that in a slide later. The stack of the VIAME Web looks something like this as shown in the right-hand side. We use Kitware machine learning software system called Quiver, along with PyTorch, as Matt mentioned. We work with the file system, whether it's local or remote. We have the software component, which enables us to do parallel processing, and for that we utilize this open source tool, Python Celery. On top of that, we have web server for doing client and server communications. Girder provides the data API, and then the front end is built using GeoJS and a modern UI framework called Vue.js. As I mentioned, we strive for high software quality, so we do have the continuous integration and testing, and we make these images available every as the code changes in our maintenance branch. and those images are available on Docker Hub. The documentation, which we continuously update, is available on our wiki page. Next slide, please, Matt. So one of the things that we really put emphasis on is making sure that VIAME Web can run in different environments. And some of you may be familiar with the technology called containerization, which essentially means that you're packaging all of the software dependencies in a container, and then that container runs on the cloud or locally on your machine. Most of the major public cloud computing services provide support for containers, and that's what we use in this instance for the tutorial today on AWS. We do have containers for web server, worker nodes that essentially do the parallel processing, and which essentially calls the backend of VIAME Web. The exception is that the desktop version that is work in progress of VIAME Web, which will be using electron.js, and that will run natively on the system. The idea here is that not only it will give you a native look and feel, but you can essentially use your files directly off the file system. So that's something is we are really excited about that we are hoping to get done in the next few months. Next slide, please. So one thing I want to highlight the fact that why it was possible for us to build VIAME Web-like applications, because most of the groundwork has been done by us in a common framework called Girder. Essentially, Girder provides a means to share data sets, which means that files or metadata or the database models. It allows us to essentially define how the users access those data sets or the jobs that they can run on AWS or locally, for example, which means that we do have the notions of permissions, logins, user, and groups. One of the things that is really makes it easy for us to build web server, client-server applications is this API that Girder provides, which essentially makes it easy for us to access data sets through a unified data API. And then it does have the capabilities to execute tasks in a parallel fashion and then do monitoring of those things through its extensions and plugins, which are easily extensible for any of the project needs. So we are showing some different instances where Girder were used in medical domain, geospatial domain, and in this case, in the VIAME Web itself. Next slide, please. Some more iterative work that we have done that lead us to doing more work in the climate and geospatial domain. So in 2014, we were working with NASA Ames on working on a Jupyter-based system that seamlessly interfaces with HPC and cloud environments, running the analytics pipeline on the cloud, and doing data processing either for data products or doing some analysis that was required by the scientist. We have been working with DOE on many projects, including CDAT, which is the climate data analysis tools that essentially allows the developers or users to analyze and visualize climate data sets. And for that project, we added a new backend, which uses Kitware's own open source toolkit called VTK for high-end, sophisticated 2D and 3D viz, as you can see in the figures. One of the projects that we are working currently with DoD is the Geodata API, which allows us to essentially doing data cataloging of all the geospatial data sets and serve these data sets to a unified data API and REST API along with the data services using OGC standards. Next slide, please. So coming back to the VIAME Web, after talking about our rich history in the climate, environmental, and geospatial domain, for this tutorial today, we have two instances. One is hosted locally within Kitware, which is viame.kitware.com. The other one, which is temporary, is on AWS, which is VIAME.fish. You can use either one of these two. If your name first name starts with letter A and G, or between A and G, you can use VIAME.kitware.com. If your first name starts with letter H and between H and Z, then you can use VIAME.fish. The difference here is that the one on site has 2 GPUs, one with 1080 Ti, and the other one is RTX 5000. We do update the internal version every Thursday and Sunday automatically through our continuous integration and deployment pipeline. The one on AWS, which is only for this tutorial today, has 4 GPUs, V800s, and that's something you can use and try it out, but it won't be available after the tutorial today. So with that, I would like to invite Brandon Davis to give you the tutorial of the VIAME Web.
All right, thanks, Ashish. Let me go ahead and get set up. Let's see what's happened here.
I just stopped sharing, so
Gotcha.
so things should be open. Yeah, just to reiterate Ashish's comment, that Amazon server will go down at around 2:30 today. We only brought it up for this tutorial because we had roughly 100 people sign up. So I would recommend definitely, if you have any annotations you've done during the course of this tutorial, to save them out. But obviously the span is sort of fast, so you probably won't get too much done on there.
All right, thanks. So this is going to be a more hands-on part of our tutorial today. If you want it to be, you can also just follow along. This is VIAME.kitware.com. Again, depending on your name, you can either create or register for an account here, or you can go to VIAME.fish and go through the same registration process. It's just stick in a username and an email and a password. You won't have to confirm your email address or anything like that. I am going to first log in here and give you a short tour of where our data is and sort of how you can get started on some data before we start looking at annotation. So I will log in. So when you log in, you will end up at a page that looks like this. This is the root of the server. Data here is organized in sort of a hierarchical tree fashion. So there are some collections, that's shared data that everyone on the server can see. And then every user also gets their own user space. The globe will take you back to the root. And the data that you're going to be interested in today is in the collections, in workshop samples, and in this example data folder. If you are able to get here, I'll kind of just talk here for a minute to give folks enough time to register and get here. There are a couple of different data sets that we're going to be looking at. We will look at some fish data, some scallop data, and we'll be looking at doing some detection annotation on sea lions. You will be able to, the quickest way to get to this is just to launch Annotator directly from the collections data set. So you can open it up. This data is available on both servers, and you can go ahead and start manipulating annotations as we go through it together. The only thing you won't be able to do is if you make a change, you'll see the Save button lights up. You won't be able to save, you don't have permissions, but you can sort of get a feel for the annotator and what it can do. If instead you would like to try and upload your own data, you can do that, and I will go back to, let me go ahead and actually, so this is, there are a couple of ways that you can get some data. One is I have dropped a link to a zip file in chat. You can download that zip file and extract it, and I'll show you what to do with that in just a moment. You can also download one of these workshop samples directly if you click the checkbox and then go to the download button. I would recommend downloading the image sequence. You will get a zip file of the image sequence that you will need to extract. And right now what I'll do is I'll take you over and show you how to upload. I am going to hop back over to an instance of VIAME Web that I am hosting locally. So, in order to avoid competing with you all for bandwidth and GPU resources, I'm just running this demo on my own workstation. But if you go to the home button, so in the breadcrumb up here, you have the root button, and you also have your home button. That will take you to your user workspace. You will have a public and a private folder. Data that you put in your public folder will be public readable by every user on the system. So if you put data in here, other users are going to be able to see and read that, but not save it. Likewise, private is exactly like it sounds. No one else will be able to see that. So what I am going to do is upload some data here. If you click the upload button, you will get a drag file or directory here. And so this is important. You can't drag one image at a time onto this, into this window. What you need to do is either shift or control click or like range select some group of imagery and drag it on all at once. And if you do that, you will get a UI that looks like this. And you can name your folder. This is some fish imagery. I'm sorry you couldn't see my data sort of from my operating system coming in. I will name this fish. And this FPS over here, depending on the type of imagery that you're uploading, if they are still frames from a video, then if you happen to know the frame rate, you can set the frame rate here. I happen to know that I think the frame rate is 10. 10 is the default. But if you are uploading just an image sequence that's not still frames from a video, I recommend setting the FPS to 1. I'm going to set it as 10. Look, start upload, and you should get a data set that looks, a folder that looks like this with a launch annotator button. Again, if you're having trouble, I would recommend going to root, collections, I'm on the wrong server, going to root, collections, workshop samples, example data, and opening one of these just to follow along with me. Looks like there's a question. How do you zoom in the annotator viewer? Yes, I will get to that actually right now. So now that we're all able to access some data set, whether it's one that you've provided or one that I've provided, I am going to show you some of the different parts of the annotator. Really quick, you can look at this documentation. There's this user guide button at the top right. You can open that in a new tab. Everything I'm about to show you is available at the user documentation page. So if you launch an annotator, you will get some imagery that loads. I have loaded an interesting data set with scallops and some other creatures here, just to have something interesting to look at while I talk. But to answer your question, scroll is what allows you to zoom in and out. And you can also hold shift and then drag a box in order to zoom to that location. Hopefully that answers your question. So yeah, this is the goal. This is what we're trying to get to, is to have a data set that is annotated, and you can go through and look. So starting at the lower left here, this is the track list. Matt mentioned earlier that the difference between tracks and detections is a little fuzzy. If you're working with video or still frames, then you're going to have tracks. If you are working with an image sequence, then you are going to have just single frame detections. But a detection is just a single frame track and vice versa. So you can select these tracks, and when you select the track ID, which is next to the checkbox, the viewer automatically scrubs to and highlights, selects that detection. You can also navigate around with arrow keys, so you can do up and down, and as you do that again, you will automatically scrub to and highlight that detection. You have a couple of buttons down here, delete, obviously. you have this little map marker, which will take you to, will locate it for you, but not select it. And finally, there is this edit mode toggle button that will allow you to turn editing mode on and off. We'll look a lot more at editing mode in a few minutes. At the bottom, there's this histogram view. So this shows you where all of your annotations are in the data image sequence. As you can see, we have 24,000 detections here, roughly. Most of them are sea scallops. So in the type filter list, if I turn the sea scallops off, you can see that pretty much everything goes away. There's only 400 detections left. And in the histogram view, you can kind of see what's remaining. There are some, well, that's not right. There are some clappers. There are some sea stars, some roundfish, a few other things, but mostly this image set is live sea scallops. Again, you can scroll down here to zoom in. You can click and drag to move around. And so those are some of the basic capabilities of the annotation view. Looks like there's a question. Looks like, should I be seeing annotations if I launch the scallop test data? No, I don't believe that one has annotations. Let's quickly revisit over here and see what has the fish training set. These might actually all be empty because the plan is to go through and annotate them together. I believe they're all unannotated. Thank you for the question. Great. I'm going to take a quick pause here. Is everyone who is able to, or maybe signify in chat, if you're able to not open one of those sample sets that you want to, just let us know, and hopefully someone will be able to help you. So that was the introduction generally to the data annotation interface. I am now going to show you on a different data set. Sea lion has annotations. Thanks, Matt. I'm going to show you annotation of single frame detections on some workshop data. I'm going to look at some sea lions that I have partially annotated, and we will complete one of the images. So I have gone through, I've done a lot of annotation, but you can see there's still several sea lions that I haven't gotten to. So great. How to create bounding box single frame detections. Again, over here in the bottom left, in your track list, there's this settings cog. If you pop open the settings cog, you'll see two different modes. And you want to be in detection mode here. So if we change over to detection mode, we can go ahead and set a type as well. Looks like there is a question in chat. I'm gonna stop and figure out what it is. It looks like another member of our team answered the question. But yes, you can expand and collapse the timeline view and the events view if you want more space to annotate. So in the annotation settings, change to detection mode. You can set the default type as you're annotating. You could have multiple kinds of sea lions. So if you wanted to differentiate bulls from pups, you could go through and do all the bulls first and then the pups. I'm just going to do sea lion to make things simple here. And I'm going to turn continuous mode off, and then I'll turn it back on. Okay, so it looks like there's a problem with my presentation. The timeline is not visible. I'm going to refresh this page, and are you able to see the histogram view down here? Only the top half. Interesting. Okay, I will continue collapsing the window. A little more. All right. That is unfortunate. I will probably stop right about there. I will just refresh again just to let everything settle. Cool. Thank you for letting me know. Great. So we are going to create some detections. I'm going to pop over to the second screen where I have not finished annotating. I'm going to make sure I'm in detection mode. I'm going to set my type as sea lion. If you don't have the type in your list, you can type something new. So it's new type. You can put in basically anything here that you would like. I'm going to go back to sea lion. If I create a detection using the plus button or the N key, so the N key and the plus button do the same thing. They allow me to create new annotations, and I click and drag. I can lay a new single frame detection. But I don't want to have to hit new every time I want to annotate a sea lion. So I'm going to put it in continuous mode, and I'll tap N again for new. And now every time I place a detection, I get a new, I'll collapse this so that you can see the full track list. I get a new track that's ready for detection to be made. And you can go through and lay yourself a bunch of bounding boxes on some seals. It doesn't really matter if you annotate the full page. We're not going to be doing training on this data set. But that is detection creation. I'm also going to show you, so this is just bounding box so far. If I select, so left click to select a detection that I've already made, you can add additional geometry types to that. So I can hit in this editing menu up here, I can move into editing mode by clicking the bounding box or right clicking. So if I right click, I can move into editing mode. And then the 2 key or that button will let you create a polygon. And so you can go through and drop all of the points along your polygon. I'm not going to do a great job of this, just sort of demonstrating the feature, but that's the idea. And then likewise, I'm still in editing mode. I can tap 3 or touch the button and put head tail feature points on this detection. So that is single frame annotation. We are going to now go look at another data set. Actually, before I do that, let's look at some of the options for running pipelines. So this is a test set, a very similar, very similar data, but not the same data for some sea lions. You can see there's quite a few of them. And what I would like to do is run a pre-trained pipeline on this sea lion imagery. So if you upload some imagery and you select the check button next to your data set and run pipeline, you will see a couple of options here. So you'll see trackers. These are for video and video frames, but we're going to look at detectors. So we have detectors for things like scallops and fish, Arctic seals, but I do have this sea lion multi-class detector that I'm going to run. And when you do that, you should see started pipeline on OneClips, and you should see a job start processing up here in the top left. And if you go over...
I'm just going to chime in for a second, but just for clarification, on the sample sequences that are in the sort of the shared sample folder, you can't run these pipelines right now. You can only run the pipelines on things in your user space. There is a admin system under the hood where only admins can run sort of the global training data spaces. But if you do want to run some of these pipelines, you can download the samples. If you don't have your own data, upload them, re-upload them to your user space, and then try to run these different detector pipelines on them. There's a number of different detection pipelines in the system. I'll cover them a little bit more what the defaults are sort of in the desktop version, but there is a default detector that sort of goes for fish. There's these more specialized detectors like scallop sea lions that are already in there. But then there's also a couple others like a generic object proposal pipeline that you could run that puts boxes around basically arbitrary things to try to speed up the process.
Yeah, thanks.
Sorry, Brandon.
No, thank you. I forgot to mention that. So yeah, this will only work on data that you have uploaded yourself. So we just looked at that data set. It was empty. I ran a sea lion multi-class pipeline. I can launch annotator again. And this is the output that I've gotten. So one thing you may have noticed a moment ago is this confidence filter. I didn't show you how it worked yet. But if you step through, this is the results of the pipeline that I've run. It actually did a pretty good job on these sea lions. But if you move your confidence filter, you can see that other detections appear or disappear based on the confidence, the output confidence of the model that was run. And so, how much false negative versus false positive you're willing to tolerate, you can control with that confidence filter. So yeah, that's all I wanted to highlight there. We are now going to look at annotating some tracks, so still frames from a video, and I'm going to do that on some fish data. So this is my fish training set. I have a complete set that we'll look at in a moment. So this is my fish training set. I think your data set looks very similar, but just to scrub through this so we have an idea of what the situation is, we have two fish, a third fish at the bottom. One passes behind the other, so that's going to be a little tricky, and then one enters from off camera. And so we'll look at how to annotate for all of those scenarios. So now in the track list, which should be empty, again, open the settings cog and change over to track mode. We're not doing sea lions anymore, we're doing fish. So I will change that, and I will turn this interpolate mode to on. Interpolation is sort of a convenient way to get a lot of annotations on a track for not quite as much effort as it would take to go through each frame and draw a box. And so sort of what that translates to, if I draw some new tracks, I'll go ahead and lay the first frame on each of these. And I think I have one more down here. So those are my initializations. If you go ahead, you can see, so there's some new things in the track list to the left, some new buttons. These arrows are keyframe navigation. I'll show you what keyframes are in a moment. The editing toggle button is still there. This sort of dotted outline box is the interpolation toggle. So if you turn that off, which I should not have done because I don't have any other frames, I'll delete that, create a new one. If you turn that off, you will disable interpolation. And then this is the keyframe toggle. Again, don't hit that until you have at least more than one keyframe. So we are in interpolation mode. And if I move, I'm going to move into the event view so you can see that I've got 3 tracks here. One is selected, and there's only one keyframe for each so far. If I move forward by tapping F or one of these skip buttons, so F and D will move you through time, you can see that this box doesn't go away. I'm in editing mode, so in order for this to happen, you need to be in editing mode, not selection mode. Right-click, make sure your feature handles are visible, and then move forward. The box doesn't move. You can move forward in time pretty far, and then when you're ready to drop a new keyframe, all you have to do is move the box, and you see how, as I drop the keyframe, this line is extended in the event view. This new blue box, which signifies a keyframe, has appeared, and the box on the annotator window became more solid. So again, I'll move forward. I've got the thin box, which means I'm ready to move my annotation. And again, I get a new keyframe. So each of these blue boxes is a keyframe, and each of the thin blue lines connecting them tells me where interpolation has happened. So if I step back through time, I can see the linear interpolation between the 3 keyframes that I have laid. So coming back to the list, the track list over here, if I wanted to go ahead and put a new keyframe down, there are 2 ways to do that. I could just go ahead and move the box. That's all I have to do to place a new keyframe is move the existing box. And I can toggle that keyframe off using the star, and I can toggle interpolation off using the interpolation toggle. And you'll see as I do that, the box disappears just in this range, and the thin blue line disappears. We'll come back to that in just a moment. I'm going to correct this because I didn't quite like how that looked. This isn't a great linear interpolation, but it's good enough for our demo. I'm going to return back to the first frame of a different track, and I'll do the same thing. I'll zoom out a little bit, move forward in time, and move my track detection box. Forward some more. And what I'll do is I'll annotate this all the way through until they start to collide. So right here is about the last decent annotation I think I can get out of this. And I will step all the way through using F until the fish sort of comes out the other side. And I will move my box and set another keyframe. But I need to get rid of all of these frames in the middle. And again, all I have to do that is disable interpolation. So now I've got a track with a hole in it, and I can continue annotating until the end of my clip here. I think that may be enough of an explanation of track creation. I am actually going to move over. So we're going to do a bit of explanation on how the training workflow happens. But to do that, I'm going to move over to a data set where I have completed this annotation. So I got all of the frames of all of the fish you can see here. And we're going to move back out to data. And I will select this data set that I've completed annotation on and click the Run Training button. There are a lot of configuration files here. They require some explanation. I will let Matt give that explanation a little later, but I'm just going to use the default for now, and I will call this fish net harn cascade, and I will go ahead and run a training session. I should mention here that the amount of data that I'm running this training with is not nearly sufficient to produce a valid model. This is more just a proof of the workflow. If you go over to jobs, you can see that that's running. But when it completes, you'll be able to see, I did this yesterday. So when it completes, if you want to run the resultant pipeline on some other data, you can select that, run pipeline, and then in the trained list, you should have a list of your trained pipelines, and you can run those against an existing data set. So that's the one that I ran yesterday. So that is annotating tracks and using some of the training features. I am now going to show you a little bit of download and export. So once you have done some annotation, and we will go back into this fish set that I completed, just because I like it. There are a couple of ways that you can download this data if you want to work with it in VIAME desktop, for example. So just click that download button. You can get the image sequence, so you can get just the images without any annotations in a zip file. You can get just the detection file. So if I click that, I will get just the VIAME CSV from these tracks. And you can download everything, which gives you both the images and the detections. And so you can hit everything. I'll get a zip file. It'll be a directory with images and the CSV. And again, you can use those with other compatible processes. I want to point out the Help menu up here at the top right next to the Save button. So I'll click Help All of the keys that I've talked about and some of the ones that I've forgotten, all the hotkeys, all the controls are going to be here. If it's not here, then it might be, again, in the user guide. And there's another link to the user guide here that you can get to our wiki. Particularly everything I've talked about with the annotation UI is laid out really nicely here. Sure, there are a couple of other things that I may have covered a little too quickly. So I will show, perhaps on these fish, yeah, I will show on this fish here how to do a polygon segmentation mask and head tail points again. So we did a segmentation mask on a seal a minute ago. You can do the same thing on track data. So if I right click to select, I move into polygon mode, I can do the same thing on just this detection for my fish. And this polygon gets associated with this track on this frame. And what you can actually do is once you've completed and you want to make more, you can just hit the F key and continue producing polygon annotations for track data. So polygons are not just for detections. You can add these on tracks as well. And likewise, you can add head tail points to track data. And these are things that will be part of the CSV download. So you'll see there's a documentation for exactly how this gets output in the CSV. There's a question, can you add a standardized species list to prevent typos and keep annotations consistent across different videos users? This isn't supported right now. What you get in the type list is just an exhaustive list of all of the types that appear in the data set that you have open. If that is a feature that is important to you, we can actually go ahead and log that. Maybe one of my team members could log that, and we can talk about adding that in possibly as a feature. So yeah, thank you for that question. So I've just showed polygon annotation and head tail annotation on tracks, as well as features, as well as detections. So yeah, I mentioned the documentation. I think that's all that I have prepared for you. But if there are any additional questions or you'd like some clarification on any of those tasks, please let me know in chat or, yeah, great. We're going to log that feature on GitHub.
I guess one other thing we didn't mention today was that on these sort of sample servers, if you're going to continue to play around with them for the duration of this tutorial, we're going to shift gears a little bit, but we purposely limited the train pipelines to only operate over 60 seconds. And there's one or two of them that just don't run because we put limiters on them. But, you know, for a typical deep model like the one that Brandon just trained up, you know, it's a deep CFRNN detector. So that's designed for, you know, deep cascade faster RCNN. And one of our test harnesses, you know, it requires a lot of data to train up. Typically, train times are like a day or two on a system such as these, as opposed to, you know, 60 seconds. So just be aware of that limitation factor. This VIAME.fish server was a temporary, you know, AWS instance for this. VIAME.kitware.com is a continuous resource. It's publicly available. There is one GPU in there that's devoted just for training and one for running detection pipelines. But when we remove these limiters again, you know, later in the week, that one GPU for training will probably be used up a lot simply because training jobs do typically take like 2 to 3 days. So I don't really count on that being there, but if people do want to try to use it, they can.
One last thing that I forgot to mention is that you can't see this. So there's a 1.5 terabytes of training data right now on viame.kitware.com. It's disabled just because we don't really have the bandwidth to support all of you trying to download these very large data sets. But after the workshop, we are going to unlock this training data that you'll be able to see. And there are example data sets with annotations, most of them, for many different kinds of example data. So there's sea lions, there's scallops, there's a lot of different kinds of fish, different camera systems. Matt can talk more about that later if there's more to mention. But that is all that I have for you. Thanks for following along. And I will pass it on to Matt again.
All right, thanks, Brandon. Yeah, I guess on that last training data note, I am still in the process of uploading some of the ones that people have done over time. People can upload their own training data again. I've maybe got about half of the ones that I know about that people have done using VIAME Online already, but there's still, I guess, half of them I have to sort. The question of species normalization did come up. That is an issue we've seen where different groups will maintain different species lists, and they do things in different formats. So some might use like Latin genus species name, some might use local names. And there's really the question there of should we standardize that, or should we rely on groups trying to standardize that, or whatnot? But I think that's an open question. By default, we let people enter any types for these things and train up models themselves specific to their problems. I guess there's the question of would one global fish model make sense, or one global sea line make sense, or whether or not models specific to local domains make more sense. That definitely is still an open question. Oftentimes it depends on how much training data is there for these particular problems, and also how constrained the problems are. So how consistent are the backgrounds? Does it make sense to train on data from the Northeast using Alaska data, or does it not? These questions come up. Sometimes it does make sense, sometimes it doesn't. It's data dependent, just like everything else in machine learning, deep learning. So I guess we have time for 5 minutes of questions before we head on to the desktop version of this tutorial. Anyone has any in chat? Have you seen any plankton training sets, or are there plans for a generalized plankton classifier? That's a good question. I don't know if people have been doing plankton. I think full frame krill classification is in there. Are krill and plankton the same thing? I'm not a biologist. I'm a computer scientist, but there is people working on krill. Yeah, there we go. Krill is a type of plankton. Thank you. I think Randy Cutter at NOAA is doing a krill classifier for penguin chem. I could post up some of his training data at some point. Don't know if I've heard of anyone else doing that, but I don't know. Realistically, though, I mean, it's not limited to particular problems. I mean, you can use this outside of the domain too. All the detectors we just showed and the ones that I'm going to cover in a minute are pretty generic. You can train them on any problems. Where you get into more specialized behaviors, some of the specialized detectors, like some of the scallop ones, some of like the stereo measurement stuff, image enhancement, some of those are fairly domain specific to underwater, but the actual detectors themselves, they're really not limited to any particular problem. A couple more questions coming in. If we have bottom of the sea images and we run the generic detector on it, would it only detect the species you have detectors for, or all objects? So there's multiple detectors in the system by default. I will cover these a little bit more in the next session as time permits. There's a default detector, there's a generic detector, and then there's lots of species-specific detectors right now in what's exposed in both the web GUI and the desktop GUI. The default detector is 2 high-level classes. It's like vertebrate, invertebrate. And then the generic detector is just a single class, so it's generic object proposal. What it tries to do is put a box around every single arbitrary target, regardless of class. So it doesn't do any class distinction at all. What we haven't done yet and provided are basically more fine-grained fish detectors. We can do that now that people are have a bit of ground truth across a couple institutions, is do like high-level familiar categories or other things. But right now, the sort of default fish detectors are just very, very high level. They're not even fish detectors. So that generic one is meant for arbitrary problems. What that generic one is useful for is the rapid model generation procedure, which I'll demo in a second on the desktop side, because it's basically you're doing matching, image matching on top of these generic object proposals. In some cases, it can speed up annotation, but it's more so used for those rapid model generation procedures. The default detector can be useful for like fish annotation and a little bit for mollusks and some other things, but the direction we're going in towards that I'm training models for now is that there's like 3 high-level detectors that are sort of domain specific. I mean, we have aerial problems, we have ship-based problems, and underwater problems is sort of a generic detector for that, and even underwater is you have 2 subcategories. You sort of have downward-facing cameras and outward-facing cameras, where motion matters a little bit more in one and less in the other, where you care more about appearance features. So we're sort of training a dedicated like outward fish detecting new default that are more domain specific and helpful there. That one has the motion fusion turned on. The traditional default detectors that we have in there is no motion fusion into detection results. So you can imagine that's worse for small object detection. What it's doing is per frame detection and then linking those per frame detections into tracks. And that's a useful distinction to make, is that in some domains motion matters a lot, in some it doesn't matter at all. Like aerial imagery, where you have very little overlap between the frames, motion is very harmful. That's one of the reasons why we're breaking these sort of 2 default pipelines up into 2 to 3 sort of generic ones that are useful to aid with annotation assists. That's really what we're trying to do. Is sure, people can do ground up annotation from scratch, but often that's a very time intensive process. So we're trying to bootstrap that with these generic models now that more people have done some sort of baseline ground up annotation. Coming back to our data store, I think right now we have like 2 terabytes stored on there, but I think probably have on the order of like 5 terabytes internally that we've received from people over time. I just haven't gotten to the point where I've sorted everything and put it on there. It's on the to-do list, sort of near term. Okay, any other questions before we get into the desktop side? Looks like we are good. I'm going to just take a second here to reconfigure my desktop monitors. See if I can turn on the chat channel. In case there's comments going on. All right, so VIAME desktop, what is it? How did I get to where I am? Let's bring up my trusty web browser here. I'm going to really start from the beginning here, just for those who might not have seen this content before. I think some of you definitely have. This is our main VIAME site. There's links to the web annotator that Brandon just showed, the viame.kitware.com one, not the viame.fish, which again is coming down at around 2:30 today. That was just a short-term solution. We brought up a EC2 instance with our Docker instance. There's also the desktop installers, there's quick start guides. To get to where I am, I went to the desktop installer. I downloaded these ahead of time. They're fairly large, they're like 4 gigs. The CPU ones are 2 gigs. There's also links to the web interfaces, documentation on here. What I'm mostly going to cover today is this quick start guide. In the very beginning, it's basically install instructions, how to run the system, how to run it on your desktop. There have been some reports. So NOAA has different IT departments across the board. There was 2 or 3 reports so far of people unable to run the desktop GUI due to antivirus software installed on their PC. I'll show you what that looks like in a minute, and you may or may not hit that issue. Different groups within NOAA again have different IT services turned on, which is a pre-warning that I did receive a couple pings about that. So I downloaded these binders ahead of time. I'm not going to do it. It takes like 10 minutes. There's really 2 places you can install the desktop version. That's not true. You can install it anywhere you want. Typically, the recommended place is to, if you do have admin privileges on your machine, is you extract it and you put it in C program files VIAME. If you do that, you don't have to rename any scripts at all. If you don't do that, there's sort of one caveat you have to do when you go to run your stuff. All right, thanks, Ashish. There's one caveat you have to do when you go to run your stuff. And that's changed one path in a script file, but it depends on which script you're running, and I'll clarify that in a minute. So my disk space was a little low on C. I didn't want to run things from there. I put it on D drive. So I will be doing that extra step for the non-typical install. To install it, I basically right-click and have a version ahead of what's in public. If you have an older version, it doesn't matter. They haven't changed much. We're up to V11.1. A 1.0 release is coming soon, but not quite. We're still sort of in the beta stage, but that's besides the point. So to get to this point, I extracted the .zip here, and then I basically right-clicked, went to extract. I use 7-zip, but Windows has its own extract all if you do that. That made this VIAME folder, which is the installation itself. And from here, there's 2 entry points where you can run things, and this is covered in the Quick Start Guide. Further, if you go through this, a new version of this will be posted this week. But it goes through the same exact procedure. You download the file. There's optional add-on packages with additional models if you want to download those too, like some of these scalloped ones. You extract it to a directory, and now we're at ways to run the system. So there's 2 core entry points. One, if you don't want to touch text files at all, you can just go into the examples file in here and launch some of the GUIs just from double-clicking scripts. So for people who don't want to muck around with text files, installing it in different places, this is the way to go. And no matter where you installed VIAME, you can do this. So you can go into the annotation and visualization example, for example, and double-click this launch annotation interface, which will bring up an interface that does things sort of similar to what Brandon just showed. We do have 2 different interfaces on the desktop side. There's not one, and I'll clarify that later on if there's time. Sorry if we are going through some of these things fairly quickly. Again, 2 hours, we can't cram everything in that we want to cover. And so we're doing a brief speed talk, but I will stick around from like 2 to 3 if people want to touch on individual issues a bit more, if there's issues on their system. This is the first time I'm running the binaries on this platform. I haven't used this desktop in a while. It took a little bit of time to boot up. So I'm in VIAME, examples, annotation, visualization. So it will take time when you launch this for the first time, the GUIs. The issue with block software that you might see if you were to encounter this would be that this black screen would pop up, pop down, you'd wait a minute, and then nothing would come up. Typically what that means is there was an error in that black screen, and that black screen, if it flashes really quick, that means that your IT was blocking your thing. There's a way, if you really want to confirm this, if you actually edit the script, I'd press right-click on there and edit. You put a pause at the end of this, and that'll tell you what the actual error is. But for most of you on government Windows machines, it was probably your IT system blocking it. And there is actually a way to disable that. If you Google that error, I'm not going to do that because I don't want your IT to be angry at me, but I'm just pointing that out there. Okay, so this is sort of the default annotator on the desktop side. I'm going to go through it a little bit here. I'm not going to cover it too much because it's sort of a repeat of what Brandon just covered sort of in detail. But this was one entry point, which is I went into the examples tree. So some of the other things in examples are things like example imagery, different sets from different domains if you want to go through there. I'll do that very quickly. And then also in the examples tree is sort of everything I described on the first slide. So different capabilities in the system. So things like scoring in ROC, generating ROC curves on test data sets. You want to know how well your algorithm is performing. You don't just want to know, what the boxes are. You need to quantify those if you're actually doing those for counting problems. Search and rapid model generation I will cover in about 10 minutes after I briefly go through this annotator using detectors in C++ code. Object detection training, which is slightly different on the desktop side. Basically, the core difference between web and desktop is that the desktop, you manage the annotation. So the CSVs, you have to track, you have to store in hard drives, you have to save out alongside the imagery. That's up to you to maintain versus the website, which sort of tracks these things automatically and tracks their history. Lastly, I'll roll through enhancement and registration. Very, very fast and fast talks at the end. Just due to the time limitations, we won't be able to cover this in detail again. So I'll go through the second way to run VIAME in a minute, but just GUI basics here. I can do file, new project. You can point it to a list. In this case, I'm going to point it to a folder containing I don't know, this small example set, which has sort of a diverse group of images from a couple different domains. Can scroll through here. Similar functionality, zoom real scroll. I can click, zoom in, go back to full frame with key presses. And some of the annotation creation options are sort of specialized for the same things that Brandon showed. So there's ways to create a track, tools create track. Also at the top here, create track, tracks and detections are synonymous. There are ways to execute pipelines, and these pipelines are the same. One thing that Brandon didn't really show in detail is full frame pipelines. So there's sort of detection pipelines, there's image filtering pipelines here, there's detection pipelines, there's training pipelines, and they're all slightly different, but we'll cover that in a second. By default, what the annotator does is it's in track mode, so that advance to next frame option that Brandon showed is sort of in place. I turned that off. But to toggle that on and off, there's tools configure, there's options, user interface, auto change frame during track creation or FSC creation. That goes to the next frame automatically if you're making tracks. If you're just making detections, you don't really care about that. So to make a detection, and this messes up people sometimes, it's on the web side, you just draw a box. On the desktop side, you don't. You hold control, then you draw the box, and then you release, and that resizes the box. There's some pros and cons to that. The pro is that if you're in track mode, you can very quickly hold control, drag the box, and do that for skipping between frames. The main downside to it, which is why we didn't do it in VIAME Web, is that people tend to mess it up sometimes, the whole control procedure. I'm holding control, I'm clicking, but sometimes people don't hold control at the right time, and they zoom instead of clicking. That's the most problematic issue I've seen giving tutorials on this desktop interface across the board. So I just drew a box in detection mode, but maybe you're doing the same thing that Brandon showed, where you don't want to hold control and click that create track button for every frame. So there's things for doing rapid annotation. If you do create single frame tracks, now it'll record my last box size, and I can click to make tracks really fast. The type system is very similar. Here we have a list of filtering options. We can turn on and off different types. I can edit the types. I can shift click, edit types in batch if you don't want to. Do this one by one. Say they're all fish, etc. If you do want to edit them by one, you sort of click this edit option here. By default, you might have a different panel on the right, but there's a view option up here. We can turn it on and off these different settings like filtering options, etc. So I can go into each individual type. I can say this is a scallop. I want my scallops to be red or whatever, etc. Save that out, etc. Sometimes the color doesn't take effect until you refresh the screen, but and for computed pipelines, it shows basically the scores. So for manual annotations, the score is 1 for these types, but for computed, there'll be a variable score. Let's delete some of these out really quick. Can I mass delete? I don't know if I can. Oh, that's annoying. That's a feature request, so I'm going to add and make sure we have on the website. There is a actually utility pipeline you can run that resets all your view. It's embedded pipelines. Is it in here? Oh, it is in here. Okay, reset. From scratch, and maybe I want to run a pipeline on this now. Run default detector. Mass delete feature would be super appreciated in track. Yeah, that does exist in the web interface. You can run. There's a utilities pipeline dropdown called like reset detections, but that deletes all detections. It doesn't delete a specified one, which would definitely be useful. I agree. We're going to add that to the issue page. So I just ran a default detector here. Spooled up this executing pipeline window. Give that a second. Hopefully I'm not doing too many things on my machine here. No, that's not good. I might have exceeded my GPU resources because that generally means I have to run a smaller pipeline. But I run the same thing through here just because if I'm using up too much GPU, this laptop has a smaller GPU card in it. I'm working from home, not at my workplace. All right, so I just ran the same sequence through just without the GUI because that saves GPU resources. But I switched examples here on you very quickly. What I did is I went into examples, object detection, and I ran the detector. I was just going to run from there. All these examples by default, they do, by the way, run on image lists, but I'll show how do you do that on videos in a minute. And so I ran this pipeline from sort of this utility. It spit out these computer detection files, which is same CSV format that Web GUI uses by default. I ran the default pipeline, which is sort of vertebrates, invertebrates. I'm going to go back to my GUI and launch that up again. And load the detections I just computed. Did that in the other example tree. I did that in object detection. A small set I ran. And these were the computed detection I produced. And now I get these beautiful color detections on this default set, which was sort of this basic vertebrate invertebrate pipeline. So if I click these computations, now you get, it's not just all 1.0. It's here's the class category, here's the score. So theoretically, I could use these pipelines to boost annotation if it's easier than doing it from scratch. Sometimes, again, it isn't because the detection pipeline performance will be worse. Sometimes it is, and it helps a lot. It really depends on how far along your models are, how well the default models were trained to your problem versus not. We definitely see some people getting better performance starting from scratch in terms of efficiency, and some people, starting from running these existing pipelines. So what do we got here? We have invertebrates. Just like the other GUI, there's confidence sliders over detectors. You can see that my list got less because as the confidence goes up from these filters, there's a lot less detection. So at these high confidence levels, the system's saying, oh, I'm much more sure that that's a fish versus these other ones. It's saying this one is 95% probability as a fish. Hopefully this one's yes. So yeah, this bush in the background is 13% probability. That's the vertebrate column, so I should be able to up yeah. So if I up the vertebrate, count for this problem, it should be better. I just ran a detector here, not a tracker, because these were sort of independent stills, not that. So if you actually want to do training from this GUI, you can. If you have a GPU that's powerful enough, there are trained detector dropdowns, trained YOLO dropdowns. The main downside on the desktop side is that you can only open up one sequence at once. You can't open up multiple annotations across multiple videos at once. To do that, what you do is you open up one annotation sequence, you save them out, you export those CSVs, and rinse and repeat for every video sequence until you build up a training data archive. And I'll show that in a second. I'm not going to do that here, obviously, because there wouldn't be much value in, you sitting around watching me annotate $10 billion here. But to annotate tracks and then spit them out again, you basically do export tracks. There's an all tracks button here. And this, again, it works for tracks or detection, so don't let the track versus detection mess you up. But there's two options. There's filtered tracks, and then there's all tracks. All tracks, regardless of your filter level, will export all of them. Filtered tracks will only export what's shown. And this is important if you're doing the correction processing as opposed to the ground-up annotations, because you don't want to train on all those low-confidence detections, because if they're on the wrong things, it's going to mess up your model a lot. For typical deep training, this is slightly different than the active learning procedure I'll show in a second. For deep training, you have to annotate everything as pristinely as possible. You don't want a lot of mistakes in there. It's going to use the entire image. It's going to sample different sections of the image and get negative examples from background content that look similar to your category that aren't. So for standard learning procedures, it's very important to not leave anything unannotated. Deep learning is the active learning thing that I'm going to show in a second is slightly different. But I'm going to save out these CSVs just so you can see what this looks like. I'll put it on my desktop, temp, and should be a temp file here. Yep. These were my corrected annotations theoretically because I set my threshold to be a value I wanted. And those are all fish now. But then this is definitely not a fish. I could raise my threshold or I could delete that. So if I was going to use this to train up a fish detector, this is looking a lot better now. So I'm going to save this again, just the filtered tracks, because I did make use of that filter threshold. I'm going to say, filtered detections. And now rinse and repeat. Maybe I've done that for a few sequences, and I have these CSV files alongside those sequences. I can now run that through my train tool. Let's get rid of that. So one way to do this would be to stick in this example tree, because I don't want to rename any scripts or anything. So I go into object detector training, and I put my data in the right format. So if you go to the documentation for this, it tells you what the format is for training on the desktop side. And I go into one of these example folders. There's sequence 1, sequence 2, sequence 3. I have in each of these folders, I have a ground truth CSV. The system does now support multiple formats. I mentioned there's JSON, but we have others like these KW18. You can ignore that for now. I would just use CSV by default. But if you want to use JSONs and some of the others, you can. But each sequence in here basically has a sequence of images or just one and a ground truth file for different videos. And they're in the example by default if you just want to look in there. So if I look in object detector training, there's a lot of different pipelines. We are in the documentation. There's a little bit of this in the quick start guide, but for example, linked from the GUI, it brings you to a page that doesn't really describe what all these are in the web GUI, but we are fleshing out that wiki page. But by default, there's probably maybe 3 detectors in here that you care about most. There's CFRNN, there's SVM, and there's YOLO. CFRNN is using sort of our train backend, and that generally produces the best results. The only problem is that it's data hungry, so you need a lot of annotations for that to train that up. We do have a lot of things in there like hyperparameter validation, early stopping, so the pipeline decides. I apologize, I've been ignoring the chat channel because I've been sort of in a group here. But if you click the X, so a track is unselected in preview panel, is it still in filtered tracks? Going back to the annotation GUI. That is an excellent question. I don't use that feature. I don't uncheck the tracks in the panel, but I don't know. I'm going to have to, I could test that later on if there's time after 2 o'clock. That would be a good thing to know. So next to each track, you can turn on and off selecting each track individually, or you could just show one track if you're interested in the desktop GUI. And I didn't show that. I also didn't show polygon drawing, which is now in there as well, and head tilt point drawing. I will do that after 2 again once I get back to that. We're getting to the end of this time slot, so I'm going to go probably at like 1:50. I'm going to go into rapid mode where I quickly go through some of the examples just to give you a quick feel for it, but I definitely don't expect you to follow along with that portion. So coming back to these different detection models, CFRNN is the default. I'd probably recommend that if you have a lot of annotations. But if you want to do sort of a fast model that works on lower number of annotations, there's this SVM model here. And there's also this YOLO model, which is sort of an intermediate. It requires slightly less annotations because it's a slightly smaller network than, say, Cascade, Faster SNN. But it's still like a deep method, so it requires a lot. What the SVM model is doing is it's basically doing this generic object proposal, which is pre-trained, and then a smaller sort of network on sort of pre-trained features and generating an SVM model as opposed to a deep model on that. So that's the output model. In these detector training examples, though, they all take data in the same exact format, and they produce an output, which is the exact same. So they produce a categories model folder with the model and possibly a pipe file. Yeah, I'm not going to show you the innards of these too much. Again, after 2, if people are interested and they want to stick around, we'll come back to whichever features you want by request. But basically, it points to a pipeline file. It points to a directory containing training data. And you run this file, and it spits out a model when you're done. So the format itself is, again, a folder of sequences where each sequence contains an annotation file and images. And lastly, there's this labels file that contains the categories you want to train models on. So the web GUI by default, it trains on all your categories, but we're adding the same capability in here, just in a graphical interface. But you can list basically, even if your annotation archive is on like 10 categories, you can train models for like 2 categories. Maybe there's 2 you only care about. When you're doing annotation, it pays to do it at a course level. That way you can come back and do this later, like your high level categories, but you have the option to train models both ways But in this file, you can specify synonyms for the same thing. So if you want to just do like maybe fish type 1, fish type 2, but have them be just one category, you can put them on one line. Or if you want them to be different categories as output by the model, you can do them multi-line. You can actually specify class hierarchies in here too. That comes up a lot. We're not actually using those in detection models yet. It trains 2 dedicated models basically across these classes, but you can specify hierarchies in there. It's not used. But say you wanted to do one high level, like genus category and the one species one. Right now, you'd basically have to train up 2 separate models, like the genus level one, where you put all your fish on one line, they'll be grouped into one category. And then like the species level one, where you break them down into a big list with all the fine-grained species. So let's get rid of those just to show you what this looks like really fast. If I go back, I train a detector. We're not going to let this run. This is a really small amount of data, so it's like 5 frames, so it's still going to take, I don't know, 2 minutes to run, which is time we don't have here. I just want to show you what that output looks like. There's 2 other things I want to cover today before doing this rapid speed talk. One is the search and rapid model generation procedure, which is the active learning. You give it an image of what you're looking for. You annotate plus minus, what's right, what's wrong. And we're going to do that very fast. And the other is project files. So as opposed to going into the examples tree, project files on the desktop side makes it a little easier to manage your annotations. All the scripts are in one place. There's just one caveat, and that's if you install your VIAME not to program files or up NOAA VIAME on Linux. You have to point the scripts and project files to your installation directory. So there's one change you have to make. But in VIAME configs, there's Proj Linux, there's Proj Windows. These are also covered in the Quick Start Guide if you're going through this after the fact. So in Proj Windows, there's 4 images, there's 4 videos. The images project is meant for an image list. So all the scripts in there are meant for a list of images, but there's also a script for helping you make an image list, make image list on Windows if you just have a directory of, say, images and you want to make a list automatically without having to edit these files. All these bat files are just links that you double click. The 4 videos folder is a little bit different. That one expects you to process either a directory of MPEGs called videos in the project file or a directory of images. It works with either. So you can still do images on the 4 videos project file. It's again, just a directory of images as opposed to one image list. By image list, I literally mean just a text file where it's like one line per list. So generally, if you're doing these things in batch, if you're generating lots of, you're processing videos, or if you're doing image lists in batch, I would recommend using these project files. Typically, you want to copy them to a directory where you have a lot of space. Like, for example, if I was to do this, it doesn't have to be in your VIAME tree. In fact, it should be outside of your install tree. I might call this great project or whatever. Within here, some things are sort of pre-made, like the training data folder, which is where with the labels.txt, where you'd want to dump your finalized training data and images. And then there's the same scripts I just showed, like train deep CFRNN network from CSV, train deep CFRNN WTF detector from CSV. That stands for with temporal features, which would be the motion detection, train deep frame classifier from CSV. We didn't actually cover this that much, but in both the website and the desktop side, there's a generate frame classifier pipeline that puts boxes around the entire frame to speed up making full frame annotations. There is a way to coming back to the questions in chat, is there an automatic way to generate the labels.txt file, or do you have to do it manually? The GUIs by default, the desktop GUI and the web GUI, they do come up with it automatically from the annotations. The train tool right now, it's not, you have to manually specify the contents, but I will add the ability to not have a labels.txt file to just have training data, in which case it will train on all categories. That's not the first time that's come up. So that will be added to the to-do list. But you see much of the same pipelines here. You also see these train SVM frame detectors, train deep frame classifiers. Again, if you want to do annotation in these GUIs, your workflow is you run that generate empty frame labels, and then you just enter the labels as opposed to drawing boxes for the full frames, which you wouldn't want to do just because that's wasted time and effort. The one other thing in here that we haven't covered yet in sort of these project files is the search and rapid model generation scripts. There's two procedures for that. There's basically create index, and then there's launch the search GUI. So this is a two-stage process that allows you to do those searches where you give it an image for what you're looking for, you adjudicate what's right, wrong, and then you go through that procedure. That can again be done in the project files or in the example tree, and I'll try to quickly go through both. Basically, it can take one of many forms. There's a question: is there any environmental data captured when the video is imported, like GPD or depth? Is that information transferred to the annotations? Yeah, I was going to ask what GPD was. So in the VIAME CSV file, you can specify notes. That's quite all right. I can't type any day. You can specify notes in the CSV file, but they're sort of detection specific. We've written out metadata in sort of separate files so far. There's only one project where we're really integrating that right now, which is some HabCam work with CFF and NEFC, where we do depth computation based on stereo depth maps. But it's not the first time that's come up because on some of the SEAL efforts, they're interested in doing that too for, say, size estimation, for subclass designation for different types of seals and sea lions based on size. The image enhancement, I believe it works on both color and grayscale. I will cover the image enhancement quickly after I'm done the rapid model generation procedure. So coming back around to what we were working on here, the search and rapid model generation, it can be run in sort of these 4 configurations. Each is for a different type of model depending on what you're trying to generate up. So there's create index, detection and tracking, which is for when you want to basically do matching over detections and tracks, not just detections, single frame detections. The search and rapid model generation GUI will return you, full tracks as opposed to just detections. It's around existing detections, which would be an existing external detections file, and you want to do IQR on existing detections that were pre-computed. Either you already annotated them or they came from an automated pipeline. Around detections is if you want to do IQR just around detections, and full frame classification would be as if you're making up a full frame classifier for, say, substrate or whatever. So the procedure for this is you call create index on your data, and then you call launch search interface that allows you to do the matching procedure. So I'm going to do this on a very small amount of data just because we're time limited here. This is still training. There's automatic loss criteria, so you see validation loss here. When that stops going down, that's when it knows it's done. There's also a time limit here. If it takes more than a week, it shuts off and just outputs the best model. But we're going to kill this off because I can't run more than 2 things at once on my GPU here because it's not a super big GPU in my laptop. So I went into the example search and model rapid model generation procedure here. Just to run this as an example very quick. I do recommend running them from project files as opposed to the example tree if you're actually doing this for real and doing it in bulk. So let's call the indexing stage, which is around detections. What this is doing is it's building up a database of these generic object proposals and descriptors around these generic object proposals to facilitate matching over them. And it's running on, I believe, my example imagery, just my small example set here, just because it's the only thing we're going to be able to complete in time. Generally, I would do this on a much larger data set, which is more meaningful when you're doing this on an archive of 2,000 plus images, these 10 images, but we're shooting to scale. So right now it is doing this pre-indexing stage on the data, consume this image list of all my imagery. And my laptop's slow today. There's 2 stages in this process. The first one is the indexing. It's making these generic object detectors, descriptors around them. You could actually see the intermediate products in the database directory if you go down in there. The second is building this searchable index so that you can do this matching across it. Okay, so that finished. Now I'm going to launch the search interface. We actually do have a project where we've been adding this into the web interface too. It is just not publicly available yet, so it wasn't for NOAA. It was for a different client. We are going through the process of getting that into the web interface and getting it in the public sphere. So I launched the search interface now. I went into image exemplar. Now I'm going to give it an image I want to search off for. And I am going to go to the example imagery folder and select, I don't know what we're going to do here. Let's do a fish, whatever. On Windows, you do see those black boxes pop up sometimes. You don't see that on Linux. Just ignore them. They're normal. When this GUI pops up, you can select what you're interested in. These are sort of generic object proposals, boxes around arbitrary things. You select one, press OK. Now you're doing a search. Across that, there's two columns here. The top list here is the closest feedback returns. The bottom list are the things that it's asking you to request. The system's asking you to do annotations on them because it's more uncertain about the annotations. So in this case, you're training an SVM on ResNet features. These are things close to the decision boundary between the categories. In this case, we're just doing a binary classifier. So you go down these lists, and these are just the initial returns, but you give the system advice on what was right and what was wrong. So this was a really easy query because the other things in the archive were all completely different types of imagery. So it's giving me back all the image types from this one data set just because it was a super easy query. But you can go through and you can mark off what's right, what's wrong. If that's a poll, so that's wrong. That's wrong again, right? Wrong. And depends on what type of classifier we're making here. Maybe we're making one specific to an individual type of fish, like a fish species, but maybe we're just making a general fish classifier. So that would control whether or not I mark this off as right or wrong. What type of classifier you're training on. So if I was going for all fish, this would be right. If I'm going for that fish species, this would be wrong. So that would control this sample. I'm going to do neither today. Going down this list, there's these, again, feedback requests. Are these right? Are these wrong? That's definitely wrong. That's right. This, again, is like a fish. So it's like, I don't know. That's a scallop, so that's wrong. Sand dollar. Then you press the refine button up here. And that generates a model under the hood, this rapid model. It re-ranks your returns so that you have new ones, and then you could go through and annotate this process again. Both lists. We're not going to do that. Instead, what we're going to do is we're going to save out this model, and then we're going to run it through our annotation GUI. So this is another way to bootstrap annotation. Maybe you want to make an SVM model first as a first pass, and run that model through the annotator. We sort of have the same workflow for pixel classification almost in place, where you can train up a first pass AWS classifier, then use that to bootstrap to train the deep models. I can execute IQR model here. I'm going to save this as just whatever fish. .svm. And now maybe we want to go through our standard annotation interface and use that. You can also sort of commit it to the repository if you want it to show up in the web GUI. So let's get out of here. We've done enough. Let's get rid of there. Go back into our annotation visualization folder here. So this is covered better in the project files, which will be the last thing I cover today briefly before going into the optional section. Is that when you save out these models, it wants it to be in this categories model directory when you go to run them in the launch annotation interface. This is done automatically in the project files. So if you train one of these models, it goes into category models when it's done, and then launch annotation interface picks up all these models automatically and allows you to run them. I'm just doing this process manually here because I'm doing it in the example folder tree. But again, I would recommend doing it in the project files because it's automatic. So I made this category model file that has my whatever fish on there. I'm launching the annotation interface. And I'm going to load up, whatever imagery. This is not what you generally want to do. Generally, you want to run your model on some new imagery it's never seen before. So this is a terrible example. What am I doing here? Doing that, execute pipeline. I just trained up an SVM detector from the rapid model generating. So I'm just going to do local SVM detector. This pulls up this pipeline. Hopefully I don't run out of GPU space again. That was a problem because essentially what's happening is I'm displaying my screen. The GUI is open at one time. Each of those things is using like a gigabyte or two of GPU. And because my GPU on my system isn't that big to begin with, it crashed that first time. So that is one concern when you're running the GUI versus the command line, because the command line lets you do reduced GPU usage. So more GPU time can be spent towards the training. But I just ran my whatever fish thing through the annotation GUI here. Similarly, I filter based on confidence, and it got these whatever fish in the beginning, but it missed all these other fish, which is what we wanted because we wanted it to only do that one type of fish. Then you can use that SVM to bootstrap your annotation process and eventually train a deep model. In some cases, that SVM model is good enough and you're done. You're done. But that depends on how difficult your problem is, how good that generic object proposal mechanism works on your problem, and a couple other factors. That generic object proposal is something that is retraining now too on additional training data, so that'll be changed shortly. Okay. So apologize again for running through these examples fairly quickly. That's due to the limited time nature of the tutorial. What I plan on doing now is staying a bit later than 2 o'clock. Officially, this session ends at 2, but I'm going to try to roll through some of these questions in chat and go through some of the other examples quickly. So if you want to stick around, stick around. If you don't, definitely don't feel bad leaving. I guess before I enter sort of the rapid fire, going through the other examples, are there any questions people want to bring up? Is the extra time recorded? I have no idea. I don't know if this session we're going to post online or not. We probably will. It can be, or we could cut it off. It's up to you guys. I mean, I'm definitely fine cutting it off and ending our tutorial here. And I'll stick around for as long as people want. If there's any issues people want to discuss in more detail. I just got to be off by I don't know, like 3 or 3:30 at the latest. But people do want to ask more individualized questions, or you can even share your screen after the fact. We could do that here if you ran into issues, or if you just want to throw me a Google Calendar invite, we can do it after the presentations. Yep. Sorry again, this was a very VIAME abridged version, but hopefully enough to get people started. We didn't cover any of the coding at all. I didn't think we'd have time for that. But again, I would refer to the online documentation for that. I can't actually see how many people are left and how many people are still here. Let me bring up that dialogue. So it looks like 49 of you are still here. So I'm now going to continue past the, I guess I should clear that with the organizers. I mean, do you want me to end off at 2, or do you want me to continue on for like half an hour going through some of these other examples?
You can continue on for a little while longer.
Yeah, like 20 minutes maybe.
Sure.
Yeah. Okay. So let's do that just because there were a couple questions there. I'll try to keep myself to 20, and then after that, if there are more individualized questions you want to ask or screen share, feel free to send me a Google Calendar email or an email right after this. I will stick around till 3:30 for any questions. Just if someone sends me 2 requests at the same time, I won't be able to answer them both. All right, so the remaining things I want to cover is sort of based on the questions I've seen and some auxiliaries. There's scoring and ROC generation. We didn't really cover how you evaluate these detectors. There is image enhancement, which is correcting the images, spitting out new images. There's both a command line and a GUI version of that. There is image registration, which I'm going to roll through in a minute, and there are the project files. So the project files I'm going to do first, then go through these auxiliary examples. So project files, they do have all these scripts in one place, which is useful. The The main difference, again, is that you do have to change the directory to where it's pointing. So if I open up one of these in a text file, you'll see at the top, C program files VIAME, which is the installation directory that I put it in. So I do actually have a VIAME installation both there and on my D drive, but my D drive was my latest one. I want to use that one. Maybe you did install it to program files and you don't need to change this, in which case, great. You can copy these project files anywhere on your computer or an external hard drive, work off of there by default. That is my recommended workflow if you are using the desktop GUI as it is right now. Eventually, what our plan is to port the web interface to the desktop, have that be sort of the default annotator that I just showed. And then, you can do everything through the GUI, training and batch across multiple folders. Right now, that is the limitation of the desktop GUI is you can't train across multiple videos at the same time, which is where these project files comes in that are sort of pre-made to do this. So I'm going to change these scripts to point to my VIAME, and that's the one thing you would have to do if you're moving them elsewhere. So how would I use this project file? Pretty much the same way. You can launch the annotation from GUI here. The one difference I would point out is video project files are slightly different than images. With video project files, you make a videos folder, you add all your videos to it. I do have an external hard drive here with videos on it, but I wouldn't cover that for just time purposes. But you put your MPEGs in here, as many as you want. Then when you press launch annotation interface, it asks you which of those videos you want to open up at once. So it gives you an option at the very beginning, which is, do you want to load one of the videos in the video folder, or do you want to just open up the annotator natively? You can actually point the native annotation software to a video directly once you load it up. You have to use these video project files if you want to load up videos themselves natively. But the workflow is you annotate the videos, you save out the CSVs, the training data, and you build up these training data folders. Launch the train scripts, launch the annotation interface, and then redo them on these on your videos, and then look at the results. Same thing with the IQ models. You create an index, you launch the search interface, you generate the IQ model, you save it out to your categories model folder, and then you rerun that SVM on new data to evaluate its performance. That's the category. That's these project files in GIST. The examples by default, they work off of image lists. Again, if you have videos, you want to do that. Also, sometimes it makes sense to, if you have videos, you just want to extract the frames. So if I look in the project file for videos, so Windows for videos, there are like extract video frames. I often like converting my videos to images and doing training and everything off of that. The reasoning behind that is videos, there's tons of different video encoders out there. And sometimes, like different software systems, they use different versions of FFmpeg that might read the video content slightly differently. So generally, if you're porting training data around, it is a little bit better to do it in images sometimes, just to avoid those issues with different types of software reading the videos differently and your frames being slightly out of sync. So generally, you can make a videos folder and still use these project files, but you might want to extract your video frames anyway, as opposed to doing raw annotation in the videos just for portability. So that's the project files in GIST. Let's go through, we didn't really cover add-on installation for these extra model packs just while I'm here, but to install them, you download the extra model packs and just copy them into your installation. So it produces, you just extract it into there. That's how you install these pipelines. And they show up in the GUIs. Scoring we wanted to cover, image enhancement we wanted to cover. So image enhancement by default, there's really 2 enhancement pipelines in the system. None are that advanced. They're all currently non-machine learning. We do have a DARPA effort where we're actually working on machine learning-based image enhancement. That's in progress. That's not on VIAME yet. What our enhancement does right now is there's 2 core pipelines, and then there's one pipeline that also has a debayering element in it. There's a drop-down for running these in the GUIs. What the enhancement process is it's just it's auto white balancing, it's gray world assumption, and then Clay-He normalization. Clay-He being adaptive histogram, which grids the image and does basically adaptive histogram equalization in different sections of the image to try and normalize color variances and illumination variances that might be from like strobe lights or something on an underwater camera system. So you can run them on the command line here, give an given an image list. Now if I run enhance here, it's like, CSI, it spits out enhanced images. This wasn't meant for this data set, so it's actually a little oversaturated here if you look at it. It's a way to export an image with its detections visible besides using the save rendered image option. Okay, that's good. You guys are actually getting down into the different options. Is there a way to export an image with its detections visible besides using the save rendered image options? You can take a screen grab in your native OS. So on Windows, you can press print screen and then copy that into MS Paint. God forbid, and then save that out. Sorry for your 2 Microsoft people who signed up, but or if you're on Linux, you can press print screen and then save it out to Linux directly. I think that's the only way besides the save rendered image to save out the images with the bounding boxes drawn on it. There is a command line pipeline that you can run in VIAME to do the same exact procedure if you have a detections file and an image list that draws them out. That's the only thing I can think of off the top of my head. So I ran an enhanced pipeline on images that didn't need it. There's also this Bayer and enhanced thing that's operating off of these example images. If you look at the list, this is like raw AUV data, so it's PGM, so they're RAWs instead of they're raw Bayered images as opposed to the native RAWs. But I can look at these; they look pretty spiffy. This is from some Northwest AUV data, which is actually what the approach in the system was tuned for right now, versus this HabCam data, which it wasn't tuned for and was pre-corrected. So I actually ran enhancement on a pre-corrected sequence, which wasn't good. So it's looking oversaturated because I'm running enhancement on an already enhanced data set using a different algorithm from the HabCam groups. So this one does look a little bit better because it was designed to run on this data and tuned, the parameters tuned for it. There's no magic behind it. I literally visually tuned our enhancement procedures. You can run these in the annotation interface. I mentioned there was a drop down. Let's kill off these windows because it's good practice if you're running multiple things just to save your resources. When you shut down those windows, it kills off the processes that are in. So I can open up. I don't know what I'm going to open here. I'll open up whatever. This is a bad example again because it's not imagery that needs enhancement, but I can run like filter enhance here, and it should spit out these enhanced images in the folder, which it does, but they're I guess that looks a little bit better. The background came out a little bit more, so those nets. So that's different, and you can actually see the shadows against the net. So it did sort of do some enhancement there. That's oversaturated again because we're doing it. Oh, that's weird. That's so it brought out the background a little bit because what that's trying to do is intensity of illumination. So it's normalizing sort of in these grid cells. You can sort of see there. I've never actually run this pipeline on this data before. So that's enhancement. And what else are we going to cover? Scoring very quickly. Silly question. After running a GUI process and closing out a window, I sometimes get stuck in a loop where database files are open in the background and I can't close them. You can log out of your user as opposed to restarting your machine if for some reason something went very wrong with the IQR stage. And people generally hit issues with this in the search and rapid model generation procedure, not any of the other things. The other things are all run and forget. They're going to run and they're going to die cleanly. The difference with search and rapid model generation is that it's pulling up a database under the hood where it's storing all these detections and detection files and things. And this database is sometimes persistent. So if something doesn't properly shut down or you can't exit out of your window or something failed, there's a small chance that that process can stay up. So to answer Emily's question about the rapid model generation procedure and whether you should restart your machine if these processes are up, you can log out as opposed to restarting, and you log out on Windows, that kills all your processes. Same with what's it called? I lost my train of thought. Sorry, mind blank. Same with Linux. So you can log out on Linux. That kills your processes. Then log back in again. You can go into processes too and kill the Postgres process in sysadmin on Windows, but logging in is always the safest thing on Windows. Generally, you don't get that process leave around issue on Linux if you're running on there. Next question. Sorry if you answered this. I missed it, but someone earlier asked about environmental/GPS data. Can VIAME load these as well? That is a mixed bag of questions. Quiver, which is a toolkit that we use under the hood of VIAME, it stands for Kitware Image and Video Retrieval. We use it for basically our video parsers and things like that. That has a metadata structure that you can read from image lists and things like that, and you can define custom formats to read external metadata. It's not something that we've really publicly exposed in any of the VIAME APIs yet, so there's nothing in there by default, but it is partially in sort of those base interfaces. That is something that is going to come up because there are definitely two groups that are sort of interested in using basically GSD data, so like ground sample distance, which is like meters per pixel, filtering that into object detectors and things like that for improved subcategory discrimination. So that is something we're going to need to address more. The short answer is yes, a little bit on the code side, but no, there's nothing directly exposed to users in VIAME or users of the GUI to import or export metadata right now. That's strictly on the software code backend. If you have a particular metadata format that you're interested in, you could send it to us. That's definitely a problem for standardization. There's no standardized metadata format. I've been pitching that here and there that groups should come together and try to come with some standards there, but it's very, very hard to get meetings to do that and get people to agree on standards. That's probably the harder fact. All right, we are coming up to our 20 minutes deadline here. We got 5 minutes left. I'm briefly going to show scoring and maybe image registration. So scoring is pretty easy. You have two CSV files. You double click a script and it outputs statistics about them. Generally, when you're doing training, you want to have a training data folder, a testing data folder, and then sometimes you have a validation folder too. Just to discriminate those three under the hood. Training is what the model is actually trained on. Validation is used for hyperparameter tuning. So things like when the model stops training, tuning the model train parameters in that NetHard framework and some of the other ones. And lastly, testing is for generating final statistics. How good is your data doing on the holdback set? So the training test divide, you have to manually partition in either the web GUI or the desktop sort of manually by holding back some of your data if you want to compute these statistics. But when you do, though, you generate ground truth on them. And then you generate your detections on them. And then you have the two files. You just double click one of these scripts. We do actually have now 3 different scoring routines in the system. The only one exposed here is sort of this original one. It's C++. It spits out, but you don't need to know that, but it spits out a couple different metrics depending on which one you're doing. I just ran scoring jointly across all, but there's also scoring jointly per category. So all is going to consolidate all your types into one category and just score them together. Per category will give you, like if you have 10 different types in your detections category and your ground truth category, per category metrics to know how good you're doing on each of them. We will expose some additional metrics in here soon from some of the other scores. So I looked at what it produced. It produced an ROC, which is typically good for measuring system performance. There's other curves too, like precision recall curves that are useful. It produced a fixed file at a single operating point, what your percent detection was, what your false alarm rate was for a detection problem. There's also a track scoring thing. If you have tracks with a lot of metrics like continuity, track scoring is typically different than things like detection scoring because there's so many caveats with tracks, like when breaks occur in the tracks themselves. Like if you have 2 tracks, but they overlap 1 track, how do you score that? Does it count as missing the target? Does it doesn't? So there's a toolkit called Quant in there that outputs a lot of statistics related to object tracking purity, fragmentation in addition to detection PDs, because when you're talking about tracking, PD is sort of irrelevant. This ROC curve is just for detections though here. So, the question always comes up is what threshold do I use for my detector. I trained up this detector, but now I need a value between 0 and 1 when I'm running this thing in operations to know what my error is for accounting problems and to choose this threshold. There are people who have done some work of doing multiple thresholds too and fusing them into a single value for counts. We haven't really integrated any of that stuff yet. But you can see here that you're basically going for, and this is a pretty bad detector, but if you actually do a lot of annotation and train it up, your performance would be much better than this. But maybe a good operating point would be here because you have a balance between false alarms and your detection PDs. This involves a little bit about the problem too, because you have to know a little bit about the domain. But basically, at this point, you could say at this threshold, this is my detection PD. How many of my categories am I picking up? And this is my false alarm rate. And then you can use that in your final evaluation. So that is scoring, and there's basically other examples here for running these tools individually, for running different trackers. I guess I didn't show a couple things in the annotation interface. I didn't show basically user-assisted tracking, where you draw a box on the first frame of a fish, launch that tracker. You could do that in the GUI or the command line here. I didn't show pixel level classification in the GUI, drawing polygons. It's much the same as the web GUI that Brandon shows. You switch the polygon modes, and then you could save out your VIAME CSVs that have polygons in them. But we're at 220, so let's call it the image registration example. There's a couple different variants. You can turn on this is getting into more niche problems for individual people, but there's this other GUI we didn't show called Seal Annotator, which is for stereo annotations. If you have optical, infrared, and ultraviolet side by side, or just two optical cameras, you could do sort of stereo annotation on the two views side by side. We didn't get into that here, but if you do use that variant of the system, there's more image registration examples in place. By default here, there's just a single one called Generate Mosaic for List, where you point it to some images, double click it, and it makes a mosaic using image registration under the hood if you want to go through there. So to use this one, there's like input image pattern. You point that to some imagery, you double click the script, spits out mosaics. And then you can actually run detections on the mosaics too. If that's unique to your problem, you don't have to do detections in the raw image space. It's really two ways to remove duplicate detections that people do is one, you generate mosaics to do detections in the mosaic space. Two is you run object tracking to not duplicate count things. And it just really fast. This will be a one. I'm switching gears here, but this will be a 1 minute demo. Then we're going to call it. Do I have good examples here? It's because I'd feel remiss if we didn't cover this. I mentioned you could do user initialized tracking. So like you can draw a box on the fish, and then run, like a. No, like track user selections fast. So that took my first box I drew on the fish. It ran a processing pipeline, which is, I have two GUIs up, which I shouldn't do because it's going to use up too much memory. But it made this 4-frame track on my target. So what you can do is you can indicate boxes for the start of each fish, run this user selected tracking to not do every single fish for the thing. The other thing I didn't really show was these generic frame labels, which put these big boxes around the entire frame if you want to do frame labels. It's grouped into the frame contents. Like say you want to annotate 1,000 frames at once with a single category here. That's what these numbers are for here. These names look slightly different than the version online. I did make a minor tweak recently just for clarity, but say you trained up a detector and you want to run it with a default tracker for tracking between frames. There's a default tracker here. So run your trained detector with a default tracker. I didn't cover tracker training, but that's more advanced. Or you could run it with a stabilized tracker that does registration frame to frame and then suppresses tracks that way. And you did the same thing with SVM models. Polygons we didn't cover, but if I do that in the GUI here, you right-click into edit mode, exact same as the web GUI, and then you draw polygon points around the target. It's not as fine-grained. And I misclicked the line there. It's not as fine-grained as the GUI, which has those big circles that you can see. Here you have to edit the line directly, but I finalize that, save out the tracks, whatever, fish. And I think that concludes our tutorial. So there are any questions now, feel free to turn off your mics or say them in chat. We are now down to 30 people. I'm actually surprised that you stuck along, but I'd probably guess that half of you are just sitting on your computers looking at other things at this point anyways. Yeah, hopefully you got something out of it, even though it was a brief preview talk. And if you're interested in learning more, feel free to reach out.
Thank you, Matt, and thanks the rest of your team for that very informative tutorial.
Nope, thank you for having us. And just the circumstances. Obviously, people are going to get a little bit less out of it than if we were in person. Usually, we do these things with like 20 people in a room. At least the first 6 or 7 we've done, as opposed to more of a presentation style thing. But hopefully, it was helpful. How do you add things to the Execute Pipelines menu? It seems like mine is missing some. So that is definitely the case on the desktop side. I just put out a new release on Saturday, which added a couple more here. B, I have all these add-on packs installed, which have additional models on them. So underneath the installations on the website page are lots of models, and each pack is like a gig or 2 each because these models are big, train deep models. And so I don't package them into the default binaries because they're problem specific and super big. But if you go there, you download these model packages like HabCam models, C-line models. You extract them, you add them to configs. They show up in there. If you're training in the project files, it doesn't actually add the pipelines automatically to here. What you do is you use existing pipelines here. Like local deep detector in the project files picks up the models you've trained with the train scripts and allows you to run them in this annotation interface. So that's not actually adding new pipelines when you do that. But if you yourself has generated a pipeline in there, this would be, I guess, slightly on the more advanced sides, but there's a config folders in VIAME where you go down and there's this embedded single stream pipe folder that has a list of the pipelines. It's a one-to-one correspondence. So everything in this folder here shows up in the GUI. So if you want to make your own pipeline that has whatever nodes in it, an image enhancement node, a stereo node, whatever, you make a pipe file, you put it in this directory. And pipe files aren't something we covered at all, but it's a collection of which algorithms are actually running under the hood, enhancement algorithms, detectors, how many detectors, fusion detectors. For people interested in fusion detectors, typically what you do is you train up 2 different models, then you make a pipe file with both detectors, you add a fusion node, and then that's your custom pipe files that you've added up.
Okay, I think this concludes the tutorial. So thanks everybody for joining us, and make sure that you log on Thursday back on the GoToWebinar for Thursday sessions. Thanks everyone.
Yep, thank you.